Products distributive property. Products, there's various type of things that they can ask you. They can ask you a term multiplied with a bracket with 2 terms or with 3 terms. They can ask you 2 brackets multiplied with one another with various 2 terms or 3 terms or 4 terms in them. And this might seem like it's all different types of things that you need to know how to do, but the basic of product stays the same. So as long as you understand the basic concept, which is the distributive property of numbers, then it's not that difficult. Now, I said in the previous video, the distributive property of numbers, we all actually know. If I multiply, say for instance, 15 times 17 with one another, what I'm going to do is I multiply, in my head I multiply 15 with 10, which is 150, and then I multiply 15 with 7, which is 105. Right, you might even break up the 7 times 10 and 7 times 5 if you feel like that, to break it up even more. But I can multiply 15 with 10 and 15 with 7, and then add these two numbers quickly to get the answer of 15 times 17. I said I can break this up even more. I can break this up even more into, I split the 10 and the 15 into 10 and 5, and I split the 17 into 10 and 7, and then I multiply this 10 with both the 10 and the 7 on that side. I must just multiply with both, which gives me then 170, which was the 10 times 17 if you remember. And then I multiply the 5 with 17, and if I don't know 5 times 17, I can break that up into 5 times 10, which is 50, and 5 times 7, which is 35. And then this 170 plus 30 gives me another 100, so that's 200, and then this 50 and 5 gives me then 255. So this procedure that I'm using here of multiplying every number in this bracket with every number in this bracket and then simplifying, but this, before I start simplifying this, multiplying this with that and with that and that with that, that's called the distributive property of numbers. And you'll see as we go along that it doesn't matter how many terms you use, the basic concept stays the same. Right, so say for instance I multiply 2x with 3x squared plus 4xy minus 2y squared. And if you're still not sure about how to multiply algebraic terms with one another, or how to add them with one another, it might be worth just watching through the video right before this one to just make sure of that. And then the distributive property of numbers says that I can multiply this number with every term in the bracket. So I'm going to do that. I take 2x, I multiply 2x with 3x squared. I multiply 2x with 8x with 4xy, and I multiply 2x with minus 2y squared, giving me minus 4xy squared. And then if there's any like terms, I just simplify this expression even further by just adding all of the like terms. But x to the power of 3, x squared y, and xy squared are 3 different terms, so I don't need to simplify this. Right, so let's look at another example. What I want to do now is, say for instance I have two brackets, 3x minus 5y, 3x plus 6y. What I want to do is I want to multiply, as with the example that I did here with the numbers, I want to multiply the 3x with all of the numbers there and minus 5y with all of the numbers there. So let's multiply 3x first. So I'm going to multiply 3x with this one, giving me 9x squared. And I multiply 3x with this one, giving me 18xy. Then I multiply the minus 5y with 3x, giving me minus 15xy. And notice there's a y and an x, and I tend to want to write 15yx, but I try to always write my terms in alphabetical order. So instead of writing yx, I write xy, because then I can easier see that these are like terms. Xy and yx are like terms, but it's easier to see xy and xy are the same term. And then I'm going to take the minus 5y multiplied now with the 3x, and I'm also going to multiply it with 6y, giving me negative 30y squared. And notice how I multiply this negative into the 3x and into the 6y. Can you see that? And now I just add my like terms. Now plus 18xy minus 15xy. I just add the numbers in front with the sign, and this stays the same. This becomes, these two becomes 3xy, and this is then minus 30y squared. Right. Let's look at another example. This one is a bit more difficult. Now I have a 2 term multiplied by a 3 term, but you'll see the procedure stays more or less the same throughout. So I'm going to first take the 4x. Let me just help myself a little bit. I'm first multiplying with 4x. So I multiply with every term in this 4x. So 4x times 3x squared gives me 12x to the power of 3. And 4x times this term gives me negative 8x squared y. And 4x times negative 6 gives me negative 24x. And then I'm going to multiply minus y throughout with this whole term. So minus y times this is minus minus 3x squared y, and minus y times this term becomes plus 2xy squared, and minus y times this becomes plus 6y. Right, and now I'm ready to go and simplify a little bit. So I'm going to search for like terms. Now there's nothing else x to the power of 3 terms but this one. So I can write this one immediately, and I'm done with that. There's a x squared y, and there's another x squared y. So I have minus 8 minus 3, giving me minus 11x squared y. And if you're still unsure when you have negative numbers added and subtracted, whether this should be minus 8 minus 3, should it be minus 11, or should it be minus 5, and you get confused, check with your calculator. Just remember to keep the x squared y there, then still after you added the numbers on the calculator, and you can't really feed the x squared y into the calculator, so you must just remember to carry that over. And then there's no other x terms, so I'm going to write this one here. There's no other xy squared terms, so I'm going to write this one here like it is, and I'm going to write the 6y, and then I am done. Alright, and that's basically the types of products that they can ask you and how you handle them. I just want to show you quickly what you do when there is a fraction involved. And it might be a good idea to pull your calculator closer when you see a product with a fraction, especially if you're still not 100% comfortable and you still have to think about the steps of doing a product. Say for instance I have 2 over 14 times 2x squared over 6 plus 5x minus a quarter. Now I can immediately see 2 over 6 can also become 1 over 3. Now you can simplify that, or you can work with it exactly as it is. It doesn't really matter. Let's stay with 2 over 6, 2x squared over 6 for now. But you will get the same answer if you work with x squared over 3 then. Right, so what I'm going to do is this. I'm going to take, you can either multiply the numerators and denominators in your head, but even 14 times 6 is 60, 84. It's 84, but that still takes a little of brain capacity. So because there's a lot of processes involved, I'd rather just use my calculator. So what I'm going to do is I type 2 over 14 times, no, I don't want the times at the bottom, times 2 over 6, and you will see I don't type a x, I just type the numbers is equal to, and it gives me 1 over 21. Now what I'm going to do with that is I fill the 1 over 21 in here, and I just keep the x squared. Now you can either write the x squared at the side or write the x squared there at the top. But when I add, for instance, x squared over 21 plus 2x squared, it's just better if I can see it's 1 over 21 x squared plus 2x squared, and I now have to add these numbers because those are like terms. Can you see this is just a better format? And since it doesn't matter whether the variable is at the top or here, I'm going to rather write it here. If it's at the bottom, I can't just write it there. But if it's at the top, I can. Right, so I'm just going to write the x squared there, and then I take again on my calculator. I take 2 over 14 and I multiply that with 5, not at the bottom, multiply by 5, giving me 5 over 7, which is the x term. So I multiplied this fraction with 5, it gives me 5 over 7, and don't forget to write the x there. And then lastly, I'm going to again use my calculator, and I'm somehow going to just take that 5 away there and make that multiplied by a quarter. Now actually this is negative a quarter, so you can either fill in the negative there, or just remember you have to minus in the equation, which gives me 1 over 28. Alright, so I'm going to remember the negative there and then put 1 over 28. So this is how I use my calculator when I do products. You can use your calculator, especially if you work with fractions. Just get the procedure right and don't lose the variable terms on your way. So if you remember that the numbers part I can multiply with my calculator, and even when I work with roots and things like that I have to multiply, you don't have to do that out of your head. You can check with your calculator, or do it with your calculator for that matter. Even if you have something like 2 times 4x squared minus 21x, and you're not sure fast what 2 times 21 is, or you're in the exam and you're under stress and you're worried that you make stupid mistakes, I can go and type in 2 times 4 is 8. So this gives me 8, and I just copy the x squared and 2 times 21. Or you can even take 2 times negative 21. But I see the negative and I just multiply the 2 and 21 and then just write the x. But don't forget to write these terms, but you can multiply the numbers using a calculator, especially when it's difficult numbers like this. And if you're not fast with difficult calculations in your head, and you to keep yourself from getting sidetracked with the whole procedure and not focusing on 2 million things at a time, use your calculator like that.